You are listening to a podcast from The Hindu.
Sometime last month, 4 British climbers climbed Mount Everest using xenon gas as a supplement, thereby completing the summit in under a week.
This is maybe one step to improve this situation and to make climbing high-altitude mountains safe.
This method allowed them to bypass several weeks that are usually spent at base camp, acclimatizing to the thin air. Xenon is a noble gas, doesn't react with other gases, and it helps the body adapt to low oxygen levels by reducing brain activity and potentially boosting red blood cell production. Since they climbed, there's already a vast literature on the ethics of this activity. Was it cheating to use artificial enhancements to scale the world's highest peak? Or it only matters that the climber braved nature at its most vicious and treacherous, namely that arduous 8,848 meter trek, and any means employed, well, short of a helicopter landing like Didier Del Sal did in 2005, is fair. Because this is Everest, the highest natural land elevation on Earth. There are human traffic jams at Everest Base Camp, many dump sites of plastic trash, and at least 300 recorded deaths so far in pursuit of this summit. There are other mountains too, meaningful in all sorts of ways to the discerning climber, but Everest is still the dream because it is the absolute highest. So Shobhana, you're a great trekker, I believe.
I have no clue, Jacob, why you have such beliefs about me. But no, unfortunately, I am not a great trekker. And, Jacob, it's not just because Everest is the highest mountain and that is why it is in public imagination. It is in public imagination also because it isn't easy to climb.
To set the record straight, I detest having to climb high mountains. I wonder why people go through that torture, but we're on the same page on this, I believe.
No, again, we are not on the same page. I would love to climb mountains, except I'm not fit enough to do so.
Okay.
So, Jacob, as it turns out, there is an epic tale in how this height was determined. And it continues to be a work in progress. China and Nepal in 2020, after a joint measurement, announced its height at 8,848.86 meters. This improved upon the official 8,848 meter pronouncement by the Survey of India in 1954. We owe these numbers to a long line of surveyors and not George Everest alone. Are we even pronouncing his name right?
Yes, as our listeners will know later on.
Yeah.
We've all probably been pronouncing that man's name wrong, and he was extremely displeased when people
would pronounce his name.
The way we all do now.
Yes, we shall get to the right name soon along. But this story actually begins from the most ambitious scientific endeavor in Indian history. The original big data exercise called the Great Trigonometric Survey. And this was an exercise that was quite uninterested in the numerical heights of mountains, but actually obsessed with something bigger, the shape of the earth. We have an elusive genius in form of William Lambton, the Colebrook cousins, the mathematical wizard Ramnath Sikdar, and it dawned on Jacob and I that this is a tale that needs to be told at a gentle pace.
I am Jacob Koshy.
And I'm Sobhana Nair, and this is the
Rearview. Here we dive into the history of things, events, discoveries, and inventions.
In this episode, we will tell the story of the trigonometric survey and the great arc of the meridian, heroically led by Lambton. Give us a brief gist of what the trigonometric survey is.
So it was an exercise that essentially started in 1802. And its broad aim was to map the entire Indian subcontinent with scientific precision. Preparing the right kind of map is a challenge because, yes, you are able to show features like rivers, lakes, mountains, but calculating distances, getting the right distance and the measure between 2 points, there can be various factors that can actually come in the way of determining the absolute distance between, let's say, one district where it starts and its actual endpoint. Indian cartography before the arrival of the Europeans were particularly elusive, in fact, actually non existent. The outline of the subcontinent appears on medieval maps of the world in more or less correct form, but its interiors, distance between towns, etc., were unknown and uncharted. The land survey and mapping of British India have advanced with the acquisitions of territory, and they began when the first battles were fought and first provinces acquired. For the East India Company, mapping was essential for control, trade, and of course, bragging rights.
The exercise of mapping began soon after Robert Clive conquered the revenue rights over Bengal, Bihar, and Odisha. Accurate surveys were necessary not only to establish the land holdings, but also for military purposes. And he found just the right man for the job, James Rennell. He is often referred to as the father of Indian geography. Rennell was the son of a captain in the artillery. He was born in 1742 in Devonshire. He entered Navy and distinguished himself as a midshipman at the seas of Pondicherry. Soon he took up service under Clive, because obviously Clive was the hero of the hour. He worked in India from 1763 to 1782, mapping West Bengal province. He published what we today know as the first atlas of Bengal. He mapped Ganga and Brahmaputra. These are still important. His maps are still important to see how the rivers have changed course over the time. Map making was another aggressive exercise by the British to possess India. In fact, the fact that Indians allowed the British to go around mapping area itself gives a clue of us.
And many of them actually found it a very strange exercise to see all these people
measuring and doing that. So it is the most obvious thing, but it hits you when you look at it closely. For example, Rennell's initial map were drafted with a European perspective. So in his maps, the British possessions are painted in red, British allies are painted in yellow, Maratha states in green, and so on and so forth. Our story, in fact, begins almost 2 decades after Rennell leaves the Indian shores. And it, in fact, begins on board a ship traveling from Calcutta to Madras, the city we call as Chennai today. On board was a 27-year-old Colonel Arthur Wellesley, who was traveling to join his brother, who was engaged in a war of attrition with Tipu Sultan. And also on the ship was our protagonist, William Lambton, who was already in his 30s. A tall, strongly built, clean-shaven man with reddish hair that's already thinning. An awkward man whose simplicity of manner gave many people very inadequate idea of his powers of mind and knowledge.
He was like this geek, like a computer geek of today, very Bill Gatesy in his teenage years kind of. without the glasses, of course.
I mean, I don't want to call him a tech bro because I think he was.
I know he was big data bro, right? Because he was measuring stuff between. I believe he helped in mapping the border between the United States and Canada.
Yes, he
And he
did.
liked measurements and
In
things
fact,
like
he
these.
was a very reclusive man. He spent a significant amount of his life in the boondocks of North America, mapping what we today know as the boundary between Canada and US. And Jacob, there's an interesting episode from his time here, which I know that you know that I have been excited about. So, if you were to look at some old maps of the time, in a place called New Brunswick, it shows a mountain which is called Lambton's Mountain. It is not very high, and its name, unlike Everest, would not stick. Instead, it today is known as the Big Bald Mountain, which was more or less what Lambton would eventually become.
That was so beautifully put by John Key, right, in that magnificent book, The Great Arc. And that is where we are drawing a lot of our
Yes.
background insight on.
Yeah.
So anyway, why Lambton is significant was because of the trigonometrical survey.
Yes.
Now, the survey essentially aims to create, the aim is to measure distances accurately. Now, how do you do that? It is by the process of creating triangles. So you start out from a determined baseline anywhere. In this case, because Madras was a province of the British. So they started out from there. And what happens is you find out 2 points, you connect them with a straight line. And then you can look at two, at the high, you identify any one feature, the height of a mountain or anything, and then use an instrument called theodolite. The whole point is you start out from one end of the baseline that you have measured. That is your one vertex of a triangle. And you find the angle from that point to this distant point that you have set. Then you go to the other end of that baseline, the other vertex. And then you again look at the angle from that particular point. So you have created this triangle, one side, two angles. And then when you go back to your high school mathematics and trigonometry, did you love trigonometry in school,
Oh my
Shobhana?
God, no, not at all. It is something that haunts me to this day.
So do you remember the law of cosines, the law of sines, or are they terrible?
They were just part of my
Words for you.
nightmare.
So anyway, you using this, what is called elementary trigonometry, you are able to then find out all the remaining angle as well as the actual lengths of the two other sides.
In fact, all those students, much like me, who hated the trigonometry, should listen to this episode because we keep asking, what do we use all this maths
When will the
for?
sine and cos ever be useful?
ever be used for? And here it is.
Yeah,
In
so-
fact,
How you do it? So then once you find out the lengths of one triangle, you use this newly acquired length as the base of another triangle. So this is like a leap of imagination. You create these particular triangles, and it's as if you are then climbing from the south and progressing all the way to the north.
Jacob, you have very casually thrown around the word theodolite. So please first give us a brief explanation of what this instrument is.
In its heydays, it was the original tool by which you are able to, like any person interested in any aspect of civil engineering or geology. Even today, civil engineers they begin to learn their jobs using a theodolite. So it is an instrument that allows you to calculate not only angles between one point and the other, but also the elevation. Like if you want to measure the height, like from the ground, if you want to measure the height of it, it has a reading. It's like a rotating scale that has to be used with great precision. And it is like it would be like a PC would be to the modern computer engineer. A theodolite is to the aspiring surveyor.
Before the Great Trigonometrical Survey began, the ship that was carrying this gigantic instrument, theodolite, sailing to India was captured by the French. It was conducted into Port Louis in Mauritius. Happily, the French authorities, when they realized what it was, rose nobly to the occasion. They repacked, and unharmed, it was gallantly forwarded to India and arrived in September along with a complimentary letter to the government of Madras.
And this was when the English and the French were at
At each other's
worst
throats.
right?
Yeah.
So see, it's such camaraderie that a theodolite can inspire.
Clearly.
So there is the creation of triangles. But Lambton was, as you said, of course, he is interested in these aspects of measurement and maps, etc. But he's interested in a larger question. I mean, this is the mid 18th centuries. People are creating maps, and people are also understanding very basic fact that the earth is round, but it is not perfectly spherical. There is no flat ground per se. Secondly, there's a big problem with the triangles. I mean, all the triangles that we imagine, we assume that they are on a flat surface. And surely you remember this, that all the angles of a triangle add up to 180 degrees, right? I'm sure you aced that fact.
I don't know why this episode is turning out to be
Your
a test
worst
of my
high school
maths.
mathematics.
Mathematical
But
knowledge.
anyway, but that's the point. I mean, because the earth is not flat, it is spherical, and there is undulations, there are heights, depths. So if you were to imagine a triangle on the surface of the earth, as I just described, its angles would not add up to 180. It could be greater than 180. So you need to calculate these exact elevations. And that is why this is what Lambton was really interested in geodesy, because already, as you've described, there were already maps made which identified features, territory, etc. But he wanted this mathematical study also to actually find out, for instance, the earth now is also flattened at the poles, and it bulges out at the equators.
Yeah, so because there was this whole discussion, whether the earth is like a grapefruit or I don't know, what was
Or
the
an orange, I
egg?
guess.
Like an egg. So egg versus grapefruit.
And it
debate.
was a grapefruit.
It was a grapefruit. Now we know.
But the thing is, even though it's a grapefruit, you now needed to put all of these into exactitudes. How much does a bulge actually amount to? And then of course, there were these emerging concepts of latitudes and longitudes. So latitudes tell you the distance of any particular point from the equator. Now, how much, because the earth is flattened over there, it would mean that even if you divide all of the latitudes, each latitude is not necessarily equal. To compute that. So Lambton was actually interested in these kinds of questions, and naturally it would mean that there would be differences in latitude, even let's say within Madras, and when you go up a little more north in central India, probably North India, etc. So he wanted to compute this, but of course you tell that to the East India Company or the surveyors, they might be taken aback by all this geekiness, but he also impressed upon them how this would be actually useful in getting an exact sense of the territories that they possessed, correcting it, and creating the most accurate maps on record.
Yeah, the interesting thing about Lambton and why we find him so endearing is that all this obsession of his about the Earth's shape, the obsession about mapping, is all self-learned. It's not that he went to a fancy school, that he was a mathematician of great
He didn't go
acclaim.
to the usual big
Yeah,
universities.
he did not. He was, in fact, we have pretty much skipped over Lambton's life story. He was born in a debt-ridden farm in Yorkshire. And it was because his parents' poverty that he joined army. And because he was very good at mathematics right from the beginning, he won a place in a grammar school. And in 1781, he joined infantry. And it is after joining infantry that he goes straight to US, where, as we have told you earlier, he worked on mapping what we today know as the Canada-US border. The beginning of the 19th century came with a lot of promise for Lambton, because being proximate to the Wellesley brothers helped him, as you just said, that he impressed upon the East India Company the importance of doing a trigonometrical survey. And this exercise begins on 10th April 1802 by measurement of a baseline near Madras. The ground selected by Major Lambton for this operation was a flat plain near 8 miles long, with St. Thomas Mount near its northern and Perimbok Hill near its southern end. And again, he uses the great triangulation method, as you just explained, to work out this distance. And these operations were conducted with great care, and he devoted 16 nights carrying out the observation. What made Lambton such a geek is he was a fiend for accuracy.
Yeah.
I mean, he would go to great lengths. As you said, they were just correcting 1 kilometer.
There was a difference of 1 kilometer
1
between
kilometer, and they took 9 years to come up with that.
for the expedition and for somebody to measure and do all of
And Lambton was the right person, because he used to obsess about every micrometer.
So let me just quote John Key on this. But April and May are hot months in Tamil Nadu. The temperature seesawed between 80 and 120 degrees Fahrenheit. Although Lambton says nothing of the inconvenience of working in such heat, he was worried sick by the variations. After endless experiments, he came to the conclusion that a 1 degree change of temperature made a difference of 0.00742 of an inch in the 100-foot length of the chain. These steel chains are especially imported from England, and because they are steel chains, they tend to expand and contract with temperature. So he was really obsessed. And if you're doing something as accurate, you actually would need to be, because if you have a small error and leave it, when you're making multiple measurements, the error just seems to accumulate. To complete the full 7.5 miles of the baseline, the first line of the triangle, required 400 individual measurements with the chain. For each of these measurements, the coffers and tripods, as well as the chain itself, had to be moved forward. It was a slow business, even after Lambton's men had been drilled to do it by numbers. The whole measurement took 57 days, and that did not include the time needed for the construction of end markers. So, all in all, this is, how he began.
So obviously, this seems to be such a laborious and such a slow-moving task. From the Madras baseline, a series of triangles. Now, you have to use your imagination. Obviously, there are no triangles drawn on the ground, but this measurement, he carried it forward towards the major plateau. And a second base was measured near Bangalore in 1804, and then it proceeded further on. Basically, what we today know as the Great Arc is the connection that Lambton drew between Madras to Bangalore.
Yeah.
Is what he connected the two sides of the peninsula.
All along what is called the 78-degree longitudinal meridian, because this is the longitude that goes from pole to pole. And this particular meridian was chosen because it is roughly the center, passes through the center of this country. As Key describes it, it is like triangles along the spine. It's like it's traversing along the spine of the skeleton that is, the structure of India.
And it is actually, it's a very beautiful picture In 1807, Lambton left the Great Arc to conduct a parallel triangulation down the east coast from Madras. This meant, in effect, continuing the short arc measured in 1802 to establish the length of a degree as a preliminary to his whole survey. Now, the government was urging him to cover the whole peninsula, and there was a lot of pressure on him. See, the thing is, with a trigonometrical survey, there is always a requirement for a vantage point, for a higher vantage point to act as.
Because you need to climb, let's say there's a hill. You need to climb on a hill and you should have uninterrupted sight. So if you're on the ground, there would be trees and structures and forests, right?
So what do you do when you are faced with a great plain?
On a great plain.
As in a great plain. So he found a way out. Basically, Lambton never really thought or looked at the world the way we normally do. Everything that had a certain height for him was a vantage point to be used, including the spires of temples. So there is this whole episode where at Tanjavure's Rajarajeshwaram temple, the British, ignoring the Indian sentiment associated with temples and the reverence with which we held the temples.
In fact, just before that, I wanted to mention the whole impression that, here is this white man, red haired, beard thinning, and he's not traveling alone. He's got a huge retinue with him, right? There is like, horses and the odd elephant, I'm sure, and multiple men, palanquin bearers with that. A theodolite is half a ton.
It's like a tractor. It's like a small tractor.
You need 12 men to actually, carry it. And they are looking for these hillocks and mountains. And, there are people climbing over there. So, in fact, there are these small hillocks, called dhrugs. And they, as you were describing, for him, everything like imposing and tall was something that, I could just climb on that. So he had his men go there, and the locals, because many of these were tribal territories, monitored, overseen by chieftains. They are wondering what kind of new invasion is this. Was still these also involved using telescopic glasses, right? So in fact, many of the people over there, the locals, would complain, and in fact, there were skirmishes, almost near skirmishes, where these people, there were accusations of voyeurism on these people. The survey instruments had the ability to magnify distinct objects, persons, or them. And
you should read out a case account of this.
Let me just quote him again. Worse still, these monstrous machines not only magnified the object but inverted it. Respectable wives and daughters going about their domestic duties were being upended by perfect strangers with lascivious intent. Cherished temples were being casually overturned, and if a well ran dry, it must be because the same troublemakers had tipped it upside down. Nor was it much good these injured people directing Lambton's men to some less objectionable vantage point well out of harm's and Harren's way. I must place myself on such hills as will describe preceding and succeeding points, expostulated one of his assistants. And in a hilly tract like this are generally the highest, and almost anywhere the stronghold of a polygar or the local chieftain. So there were all these interesting challenges, but on to the temples.
Yes, so on to the temple. We are now at Tanjavure's Rajarajeshwar temple, where he wants to take the theodolite up the temple spire because that is the tallest thing around. And there comes the wrath of the god. The theodolite crashes even before it reaches the summit and comes breaking. Thankfully, it was still in the box, so it did not break into multiple pieces. But the cost of repairing the theodolite was still very steep for the time. It cost some 650 pounds, and it was entirely borne by Lambton. People were actually very awed by Lambton's reaction to the event. Anyone in his place would have actually felt extremely hopeless and depressed. Instead, Lambton just took it in its stride and carried on, and he actually secluded himself and went on and got it repaired. Till it was
He
repaired,
pretty much fixed it himself,
he
right?
fixed it himself.
And there's also another aspect to measurements, because there is measurements and then there is calculations, because like we mentioned, this is actually a big data exercise. There are like lines and lines of calculations where these are all equations that you have to solve. And there's a nice way of that John Key has actually described it. Trial and error leading to constant refinement played no small part in the geodesist science. His situation was like that of a farmer trying to sow his drill evenly with an uncertain number of seeds. When the seeds ran out before he reached the end of the drill, he must needs go back and respace them. And likewise, if he came to the end with seeds to spare. Repeating and reviewing past work was as important as prosecuting new work. This was somebody who prided on doing his calculations himself. Now, I don't know, it was also because of how much did he trust his the assistants that he had. And he had this one very famous assistant who we will talk about in much greater detail in the forthcoming episode. But it was this constant calculations. In fact, Lambton had first accepted Sir Isaac Newton's figure of 1 by 230 for the compression of the Earth's spheroid at the poles. That is how much it is flattened. And over time, he himself corrected it to 1 by 310 through his calculation of the great arc. And it was this calculations that actually would kind of upset the authorities, because they would, as you just mentioned, there are simpler and quicker ways of doing it. But it also required several astronomical officers. You need professional astronomers, who can take accurate star-like measurements. On the contrary, that is obviously this is 18th century, early 19th century India. So it is much less easier to just go about this laborious way. Of course, the only problems you really have is the terrain, but that's when you have the hardy Indian retinue on hand, and then you have this calculations that is essentially left to one guy. He spends time and he gets everything right. So this constant tension was always on whether there are better and faster ways to do it. But as we shall eventually see, it is because of the exactitude with which Lambton actually went about this process that you were able to deduce much more astonishing things about the geography and structure of features in this country.
It would be a miss on our parts if we don't talk about that. In a lot of Lambton's work, there was a huge contribution of the great retinue of people who worked for him. And he commanded a loyalty that had not been seen so far. Another thing that John Key underlines about Lambton is, unlike others who succeeded him, Lambton was never antagonistic to Indian cultures. He did not operate at a level of at an elite looking down upon the masses. He worked with them. He worked and he mingled with them. And also we have to talk about the great dangers that this survey involved. Many lives were lost while tramping around in the jungles.
Yeah, mostly to fever, actually.
Yeah, because
but we shall actually be discussing a lot of
fever
it in
and
our
typhoid and other things.
Episode.
But the interesting thing about Lambton is, in all the notes that he has left behind, he never wrote a single line about any discomfort, personal discomfort. He was a man who was literally possessed.
He was like a rishi, or those guys, who used to go to mountains and do tapasya.
And his tapasya involved numbers and mathematical certainty. That is what he drove about. And why, by now our listeners must be wondering, why are we talking on and on about this curious man and talking about drawing imaginary triangles on the ground? Because this is, and here again I will quote John Key because I found this line as beautiful, a very beautiful line. The painstaking measurement of the meridian up through India's burning immensity would make possible the measurement of the ice-capped Himalayas. This is the story of both, of the Ark and of the mountains.
And next time, we will actually see his most famous assistant and the guy who eventually became the Surveyor General after Lambton. And what he learned, was he always a fan of Lambton? Did they disagree?
Yes.
And ultimately he...
Should we just give a small hint of who we are talking about, Jacob, if it is
Go
not
ahead.
as obvious?
Let's do the teaser.
If it is not obvious as of now, we're talking about none other than George Everest.
And we shall continue to mispronounce that name until the next episode.
Until the next episode. But George Everest worshipped Lambton. And we will know more about George Everest. But let me just leave you with these words of Everest about his boss, Lambton. He said he did not show any symptom of more than common powers. He seemed tranquil and exceedingly good-humored person, very fond of his joke, partial to singing glees and duets, and everything, in short, which tended to produce harmony and make life pass agreeably. But when he arose himself for the purpose of adjusting the great theodolite, he seemed like Ulysses shaking off his rags. His native energy appeared to rise superior to all his infirmities. His limbs moved with vigor of full manhood, and his high and ample forehead gave animation and dignity to a countenance beaming with intellect and beauty.
So for somebody so formidable, it turns out that when he passed, he was actually in pretty much an unmarked grave somewhere in Hinganghat, which is, I guess, somewhere in Vidarbha or
Wardha district.
In the Wardha district.
He was actually traveling to the current day Mumbai to carry on, to move the Ark forward.
In fact, it was a detour. Instead of he took this little, because Bombay was now becoming an important center for the company. And because they were encapsulating this too as part of the territories. So the Ark actually took a westward turn. The triangles actually moved a little to the west. And it was in the process of this that, I believe he passed away quite peacefully.
Yes,
and happily.
He died in 1823. And again, we know from Everest, because this is what he wrote, so tranquilly and calmly had he breathed his last that no one was aware of his death. Lambton died as unobtrusively as he had lived. And by the time he died, Lambton had completed triangulation of 1,65,342 square miles at a cost of 83 lakh rupees. And I'm talking about the first few decades of the 19th century. So you can imagine if you were to calculate it against the inflation.
Yeah, that'd be.
This was an astronomical.
Zeros or
yeah. So we'll be back in the next episode, Jacob.
And we shall, like the connecting triangles which are still in South India, we shall show how these triangles eventually made its way north, and ultimately how it kind of connected to the big question of how we started this episode, Mount Everest.
That's all we have for today. It's goodbye from me, Sobhana.
And goodbye from me, Jacob. See you next week.